Hello everybody, thank you for watching. This is our 3.9 video, Periodic Trends Day 2. In this video, we're going to talk about ionization energy. In this video, our objectives is to talk about the trend for ionization energy and compare that with the trend to atomic radius. So let's quickly review atomic radius and the general trend. We know going from right to left on the periodic table, you can see that our atomic radius is going to increase because the distance between half of the nucleus and half of the atom is less for oxygen and more for lithium. As you're going down, lithium's atomic radius is less than the atomic radius for our sodium atom. Also, as you're going down the periodic table, the trend is also increasing. So thinking back to atomic radius, we want to ask ourselves, why is it possible that the larger the atom it is, it's easier to remove its electrons? We know that all elements want to have 8 electrons, like our noble gases, on their outermost shell. So if you take a look at lithium, lithium only has 1 electron on the outermost shell, the valence electron. Sodium also has 1 valence electron. If you take a look at oxygen though, oxygen has 6 valence electrons, and those are the electrons that are on the outermost shell. So if all elements want to have 8 electrons, what's going to happen is electrons can be removed or gained on the outermost shell to have 8 electrons. So this is where ionization energy kind of plays a role, because ionization energy is the energy required to remove an electron and turn an atom into an ion. And if you remember what an ion is, it's when your number of protons and electrons are uneven, therefore resulting in a charge. So if you take a look at lithium, we only have 1 electron on the outermost shell. So the energy that's going to be required to remove this electron is going to be less than it is to remove 6 electrons from the outermost shell of oxygen. So we can say that there is a general trend on the periodic table regarding ionization energy, right? Because if you take a look at our atoms again, lithium, since it only has 1 electron on the outermost shell, it's going to be much easier to remove that 1 electron than it is to remove all 6 electrons of oxygen. Therefore, the general trend for ionization energy is going from left to right on the periodic table. Your ionization energy is increasing because it takes more energy to remove electrons from the outermost shell. Also, going from the bottom to the top, your ionization energy is again going to increase because it takes more energy to remove electrons that are closer to our noble gases, because all elements want 8, than it is going to be for elements that are further away from our noble gases over here. So let's try this problem. It's asking us which element has a lower ionization energy. We know ionization energy increases from left to right on the periodic table and bottom to top. So therefore, this element is going to have a lower ionization energy than this element over here. What about this one? Which element has a higher ionization energy now? Right? So this is the general trend for ionization energy, and we know because ionization energy increases left to right, this element, it's going to be harder to pluck their electrons away from the outermost shell than it is going to be for this electron. This element is closer to our 8 electrons for noble gases, and this element is further away. So how can we relate ionization energy with atomic radius? So we learned about atomic radius in the previous video. The trend for atomic radius is going right to left. Your atomic radius is increasing. Going top to bottom, your atomic radius is also increasing. Ionization energy and atomic radius is inversely proportional to each other. So what that means is the higher your atomic radius, the easier it is to remove their electrons. The smaller your atomic radius, the harder it is to take away those electrons. So these two trends are opposite of one another. And I hope this video helps learning about ionization energy.